Good morning, all. Education is the manifestation of the perfection already in man. With these thoughts of Swami Vivekanand, I would like to invite you all to the fifth day of the Faculty Development Program, come short-term course on recent trends in computer science. Based on IDC report prediction, the global data volume was predicted to grow exponentially, and by 25, it has predicted that there will be 163 zettabytes of data. Handling and managing these big data is a crucial task. In view of these things, I would like to invite today our eminent speaker, Dr. Shelly Sachdeva. Dr. Shelly Sachdeva is currently working as Associate Professor and Dean Research and Consultancy with National Institute of Technology, Delhi, India. She has received PhD degree in Computer Science from University of Aizu, Japan. She is having more than 16 years of experience in the area of teaching and research, and her main research interests are in the area of database systems, high-level query interfaces, security in databases, computational intelligence, interoperable electronic health records, and data quality for health informatics. She has also received Japanese MEXT scholarship and is also awarded gold medal for Masters of Technology in Computer Science. She is a reviewer and member of several transactions and international conferences, including IEEE. She aims to mount women in engineering and so is a member of Association of Computer Electronics and Electrical Engineers ACEEE, CSTA and Open EHR organization, and has published more than 60 articles in reputed national and international journals and conferences. I would now request ma'am to start the session.
Thank you so much, Namitaji, for such a warm welcome. And thanks to Dr. Kavita for giving me this opportunity to interact with all of you. So now I would like to share my screen with you. I hope my screen is visible to everyone.
Yes, ma'am.
Okay, thanks. So I'll start with what we are going to learn during this particular 2 hours of session. I'll be briefly introducing you what a big data is, and I'll be giving you an overview of what a data science is. Then we'll be learning about various myths that we as a researcher are usually having into our mind. While we usually have one term called as big data, we usually have another term called as a data science. So we basically will start with what is the difference between the big data and what is the difference between data science. Usually some of the people are using it interchangeably. So there are certain myths about big data, and I'll be just trying to clear those myths. So I'll be talking about the myths, I'll be talking about the realities. In the data science, I'll be introducing you, is it a single particular domain area or is it an amalgamation of different particular areas? Then I'll be talking about what are the various roles of the data scientist, and finally I'll be concluding my slides. So let me start with something just to clear with what a data is. Okay, I'm simply talking about 160 by 110. Okay, so when I'm talking about 160 by 110, I'm having some data with me, but does it make sense to anyone when I'm talking about 160 by 110? So nobody, the person who is a data scientist or the person who is working into an area of a databases will not be able to understand what I'm talking about. Okay, so that means I'm having some data, but that is completely raw. So I added a unit to that particular thing. For example, I added 160 by 110 mm per HT. So we are able to understand, okay, that makes some sense, and that may be a blood pressure of a particular patient. So I converted the thing that was very raw into something that has created an information for us. So now we have analyzed that I'm talking about the blood pressure of a patient because I've appended the unit 160 by 110 mm H3. Okay, now what is the normal range of the blood pressure? So if we are talking about the normal range of the blood pressure, usually 80 by 120 mmHg is the normal range of the blood pressure. I'm talking in general for a normal person. I'm not talking about the kids. I'm not talking about the elderly people, I'm talking in general, okay, the normal blood pressure is 80 by 120 mm per Hg. But this particular range is not matching with that. So it says that the systolic blood pressure is going beyond that particular limit. So we analyze, we are talking about the context. We analyzed and we extracted the knowledge from that information. So patient X has a very high blood pressure. So it is being analyzed from the information, it is being extracted from the information, and that particular terminology is referred to as a knowledge. So patient X has high blood pressure. Okay, and finally, when we talk about and we give some particular suggestions to that particular person, okay, you need to be investigated for your hypertension because you are suffering from a high blood pressure and you need to go to the cardiologist. So that thing becomes wisdom. So when we apply the knowledge, then that thing becomes the wisdom. So we had created a decision support kind of a thing for that particular person that, okay, you are having a high blood pressure, so you are suffering from a hypertension, and the suggestion is that you should consult the cardiologist. So this is what basically the life cycle is. So when we on the client side are starting with, we are just passing on the data or we are passing on very raw information to that particular industry or to that particular company. And we say, we would like you to create an information system for us. And once the information system is being developed, we say, okay, start making it intelligent so that it should suggest some particular things for me. So this is the whole story is. Where we start with the data, we want an information system and we are trying to extract the knowledge from it. And finally, we want a wisdom from it. So this is basically what the target is while I'm talking about a big data, while I'm talking about databases, or while I'm talking about a data science. So I'm very much clear with the data. I'm very much clear with the terminology of the information. I know what a knowledge is, and I am very much clear about how to convert that particular knowledge into a wisdom. So now everybody says, okay, what is big data? Is it just about the volume? I say, okay, I'm plugging and playing with the gigabytes of data or petabytes of data, or somebody says, okay, I'm working even with the GBs of data, still I'm considering my data to be as big data. So is it only the volume that usually quantifies, okay, this is a big data? Or how should we qualify this particular thing that we are talking about a big data? Yes, I would like some participants to interact. If in case they have the possibility to unmute themselves, can they interact? Namita ji, is it possible for participants to unmute themselves and can they interact? Okay, they can just have a chat. Okay, fine. I'll proceed and later on maybe you can ask the questions in between. So what, while I'm talking about the volume is, I'm talking about the bytes of the data. Okay, so big data says I'm having 4 particular characteristics. Earlier, it just started with very basic 3 characteristics of big data. The first one was dealing with the volume. The second one was dealing with the variety of the data. The third one was dealing with the velocity of the data. So only these 3 were the predominant characteristics that were characterizing the big data. But then when we are talking about volume, it's very easily measurable in some particular terms, and that particular terms are called as the bytes of the data. While I'm talking about the variety of the data, what do I mean by variety of the data? Variety of the data implies that my data may be of a structured form. And what do I mean by a structured form is, for example, if I see a 2D matrix, right? So 2D matrix has something organized into the form of the columns and something organized into the form of the rows, right? So something very similar to a 2D matrix is referred to as a relation in a database, and that is a RDBMS, Relational Database Management System. So it has a very predefined structure. The table has a very predefined structure into a form of a column, where the column defines the attribute names and the rows defines the tuples or the data belongs to those particular attributes. So it's very structured, right? And when I'm talking about the semi-structured data, semi-structured means if you have ever clicked on any particular web page, right? Just right click the web page and see view source. So what we'll be seeing, we'll be seeing certain tags. Okay, you'll be seeing certain tags starting with a tag XML, then source is equal to this, then you define XML with another tag, then you have a slash XML, right? So that particular thing is referred to as semi-structured data, where we have the data. Okay, we are starting with an HTML or you can also refer to as an HTML where you have a body, right? A body as a tag, and then inside it, you write something. So that is the data. So you have a structure that you are defining a body, and a slash body is the structure. But the thing that is inside that particular tag is the semi-structured data to be displayed on the web, right? So similarly, JSON are an example of semi-structured. This one, the XML is an example of a semi-structured one. Now, what is an unstructured data? So while you are dealing with the video files, right, you are dealing with the images files. So those are referred to as unstructured data, right? So the big data second characteristic, where we are talking about the variety, has structured, semi-structured, and unstructured data. Then the third is the velocity of the data, right? So that is the speed of generation of the data. For example, while you are moving on to Google Maps, okay, so what happens into a Google Maps? Your location is here. If you are traveling from, for example, Sonipat to Delhi, your location is at this particular place, then your location is at this particular place, location is at this particular place. So the speed of generation of the data is quite high. The time which the Google Maps suggests for traveling from Sonipat to particular Delhi usually increases or decreases depending upon the traffic throughout the day. So, but the data is being generated. So it's not only me who is generating the data. It's all other people, those who are traveling through the route of Sonipat to Delhi, might be making use of a Google map, and they are trying to generate the data, right? So their particular location is being tracked, and then it is moving on. So it's the speed of the generation of the data. So you have to deal with the velocity of the data, right? And after that, after these three V's, later on it was introduced another 4 V's that are also important, although that may be derived from the previous one, but that particular V referred to as the veracity is the trustworthiness of the data. How accurate the data is. Was there some particular noise of the data? Because the data quality is a very important factor when we are talking about the data. If the quality of the data that we collected is not as per the requirement, then the complete analysis of the big data life cycle is simply a waste. So the data quality is a very important factor when we are trying to analyze the data, when we are trying to do a data science on that particular data. So that is why a 4V was being appended to that, and that was referred to as the veracity of the data or the accuracy of the data. So this particular 4 V's are quite clear to everyone, and everybody knows about it, right? All of us knows about it. But what happens? What are the various myths? I'll talk from an industry perspective, and I'll talk from an academician perspective. I'll refer to the particular myth, and I'll show you how we as an academician make fool of the big data, and how the industry people make this big data as a hype, and then they present it to the customer. Okay, we are charging this much because we are dealing with the big data. And we as an academician which want our research paper to be published, so we'll plug and play with something and we'll show, okay, this is the efficiency and this is the accuracy. So we are dealing with the big data. But in actually, are we dealing with all these characteristics of the data simultaneously, or is my data set referring to the volume, the variety, the velocity, and the veracity, the complete parameters? Or am I still making it as a hype or just showing, okay, this is the volume and with this many number increase in the volume, this is the particular graph? Or am I devising a new algorithm to deal with this particular data? So maybe I may be increasing or devising or ensembling an algorithm, right? And then showing it, okay, my algorithm performs better in terms of this particular parameter as compared to the previous algorithm. So this ensembling of two algorithms may be a better approach, and this is that how I should get my research paper published? But if you are sending your paper to a very good forum, I'll talk about the forums also and where to publish and where to read the papers from the big data and the data science. And if in case you really would like to see some real reviews, you really would like to receive, then I would recommend you better, first of all, in the first submission, send your papers to those communities. And all the big data database researchers are working on into that community. Even if your paper is rejected, you'll get a marvelous review for that particular paper. So this is how we usually prepare our paper. If we are thinking something, so then they usually teach us, no, you are just talking about one particular parameter, and for the other parameters, we're not talking about. Right. So I have referred to some of the papers from very good researchers from the database community only, and I have made all my slides as per my understanding after amalgamating those research papers. Okay. So the first one is, what is a data science? So what is a data science is, I'm just giving a brief definition as of now, and will later on move to the data science. So this is what I was talking about. When I'm talking about a data science, or we see into a link, then the job is for a data science. So is it for a particular computer scientist, or the one who has graduated with a BTech in a computer science is the one who can be a data scientist? Or was it that data science is just has entered into the domain right now, and earlier people were not plugging and playing with the data science? People were not doing data science. Was it like that? No, it was never like that. Okay, so data science is an interdisciplinary field. So if you see these circles, I can see computer science, I can have a mathematics, I can have a domain knowledge, and at the intersection of all these three domains, I'm talking about the data science. So that is why I'm calling the data science as an interdisciplinary field. That is including mathematics, that is including, and inside that mathematics, mainly the statistics. So the statisticians were the ones, those who were initially doing data science. It's not that data science has just emerged as a research area. The statisticians were already doing data science. Then computer scientists are of course doing it, and the domain knowledge related to that particular domain is there. Because right now it's not that only the computer people are the one those who are doing or applying the data science. It's the healthcare domain experts are making use of their domain knowledge and doing the data science. It's the banking sector doing it. It's the person who is working into a biological stream are doing it. The astronauts are even making use of it. So that is referred to as a domain knowledge. But the thing is that you are being provided by an authenticated data, right? Environment, you are being provided by an authenticated data, environment, and critical thinking. So if somebody asks you what a data science is, you should just remember this particular small diagram, and then these three words where I'm talking about an authenticated data, environment, and critical thinking, right? And what is the output, right? So the output is used to extract the useful statistics, right? So if you see this, the output data products are actionable insight, right? So when we started from the data, we finally achieved what? Wisdom. We moved on from the left-hand side. We started with the data, converted that into an information, extracted the knowledge out of it, and finally the product was wisdom. So the decision support, the wisdom, the knowledge, or the intelligence, you can refer to those as the data products that you are trying to get from doing a data science. Okay. Now this is just to show you, okay, what is the volume you are scaling up. For example, these many people were there, they were producing 100 terabytes of data, then 40 zettabytes of data, and 2.5 quintillion bytes of data, right? So every day. This is how usually the big industry market, right? So the big industry thus says that, okay, you are on a daily basis generating 40 zettabytes of data. For example, they want to gather some particular business from an Amazon. They say to the Amazon vendors, okay, you are generating this much amount of data every day, right? And do you have such a good system which can deal with this particular thing? Then of course they may be saying that no, and we don't have such kind of a decision support kind of a system. They say, okay, so this is one of the marketing style from the industry, because industry wants money. So industry will market it like this. Okay, we are playing with this 40 zettabytes of a data and we'll be able to provide you a wisdom on the top of it. So correspondingly, you may consider the information system, or you may consider the product that we are offering to you. Okay. So because it has a quite measurable, in terms of performance, it has a quite measurable kind of a thing. But while talking about a variety or the velocity of the data, they don't have some measurable parameters. While handling with the variety or while handling with the velocity, you don't have a specific parameter. You can say that you are dealing with a structured, unstructured, and a semi-structured data simultaneously, right? For example, do you think that the Facebook, that is the social media website, is just dealing with a single variety of data? Have you ever thought of that the chats that you are doing with your friends to friends network? How is it? Is it something like a very structured form? Or it can be something like an unstructured also. And while you are giving your username, your password, this particular information is quite structured. So everybody who has to log in into the Facebook has to type the username, has to type the password, and has an option of doing the settings, right? So these are some predefined parameters, right, which everybody has to do. So that has a very well-defined structure. So I'm assuming that Facebook, for storing these kind of informations, will make use of one particular database. But what about chats? You have a friends of a friend network. I'm having 500 friends in my friend list, but I'm not chatting to all those 500. And if I make a structured form of that, what will happen? The space wastage is there. So it means that I may be chatting to my 2 or 3 or at the maximum 10 friends, but I may not chat with all 500. So it means that I cannot store that into a structured form. It means that the Facebook is dealing with something which requires this kind of an information to be dealt with. Okay, and then next is the kind of an information where you are storing friends of friends network. So friends of friends is usually represented into a form of a graph, right? So friends of friends is usually represented into a form of a graph. So that kind of an information is also being stored by the Facebook. So you are dealing with a variety of the data. You're dealing with the structured data. You are dealing with the unstructured data. You're dealing with the images and the posts. While you are posting on a Facebook, you usually attach an image along with that. And you usually say, well, this post should be into a public domain or a private domain, considering your security or privacy concerns. So the Facebook is dealing with a variety of data. Okay. And then is velocity of the data. So if I talk about an IoT, right, IoT sensors usually produce data. If you have ever been entered into an ICU, you see a constant monitoring system is there on the left hand side of yours, which is constantly monitoring your blood pressure on a frequent interval of maybe 10 minutes or maybe 15 minutes. Right, so they deploy some particular sensors over here that automatically start measuring your BP. And if you are being entered into if you are being examined in a CPU, for example, for an hour or so, it means that that much amount of data was being sent. And the velocity with which, and another example was the Google Maps, which I had already shared with you. So what has to be done? You have to analyze the streaming data. right? You have to analyze the streaming data also. So while we are recording on a YouTube, that also is real-time streaming. So if I'm talking here and somebody is projecting my lecture on a YouTube, it means a live, real-time streaming of data is happening at that particular place, right? And of course, the veracity of the data, if I have to deal with the quality of the data, of course, I have to talk about the veracity of the data. Right. So this is the volume, this is the velocity, variety, and veracity. Now, why I'm trying to make you understand these particular concepts, so that while I'm talking about the myths, I'm talking about the reality, you should be very much clear with these particular terminologies I'm talking about. Okay. So I'll start with my first myth. What my first myth is. So the first myth is, I would like to shift it to some other place so that it should not hinder my slide. Okay, let me place it at the bottom. So the first data myth is size is all that matters, right? Whenever I'm talking about a bag, right? So while I was taking an interview, I just asked the concerned faculty, the one who appeared for a guest faculty interview, okay, how will you define big data? So the term, as soon as the big implies, right, they just talk about indicate the size. Right. So very quick answer to that is, maybe later on, if you ask some more parameters and details, they may raise the issues of the volume, velocity, variety, and veracity. But in the first term, they usually indicate the big as the size. So is it true that size is all that matters? No. The reality is that size is not the one that matters. And what are the reasons behind it? I told you there are people who are working into an industry. There are academicians like us who are working over here, right? So it's just to show the measurement. How should I show? How should I show, okay, this is the measurement for volume, this is the measurement for velocity, or this is the measurement for variety, right? So variety is something very much difficult to measure. Velocity may be somewhat easier than that, but the volume is the one which is very easily measured, usually in terms of bytes. So that is why the first big data myth, that size is all that matters, is a myth. Reality is not that, right? So if there is no measure for the variety or the velocity, how will you track the progress? How will you show to the concerned? Whether you are working into an industry field or whether you are working into an academia field, how will you show? So it's very difficult to convince the other person on the other side to show that you are really dealing with the velocity and you are really dealing with the variety of the data. Okay. So handling the volume, the industry will show, the measure against some benchmark, the academicians will show an algorithm scales better than the competition. So this is usually how we publish, right? And handling with the variety is, as I already told you, that I don't have some certain measures against which parameters I should show how to handle the variety, right? So to claim it becomes a marketing hype. Then measuring the veracity is, of course, I told you that's easier than handling the variety, but it's still difficult to measure even the veracity also, right? Then before moving on to the next myth, right, I would like you to know and see this particular thing where the different companies are making use of different algorithm architecture. So there's Google, there's Microsoft, there's Amazon, there's Cloudera, right? These big companies are making use of different algorithm architecture. So if you see in the big data story, they are making use of this. In the MapReduce, they are making use of App Engine, Hadoop, and all this. Then in the relational databases. So this is just to give you an overview of that different companies are making use of different algorithm or making use of different architecture for different purposes, right? So is the myth number 2 is right? So is big data. The central challenge of the big data is that of devising new computing architectures or algorithms. Is it that way? Right? So when we usually are writing a paper, we usually think of, okay, let us devise a new computing architecture, as if, for example, Hadoop or this particular new product into the market that has been launched. Let us devise a new computing architecture, or let us give a new algorithm. Right? So is it the central challenge with the big data? It's simply a myth, right? So it's simply a myth. But how come? How come you usually certify this thing in what the reality is? First of all, let me talk about a threshold, right? What is the threshold to call something big? Is there a threshold? Let me move on to the older times. In the older times, what we were doing? We were calling, when we were not having the memory as a chief, we were not having the data collection as a chief thing, we were calling, okay, we are dealing with this, and we had a threshold. But that particular threshold was the limit that we were defining how to handle, right? So threshold, but later on, when some particular architecture changed and the particular cheap storage came, we changed the threshold. Right? We changed the threshold. First, the threshold was being defined as the limit, what we know how to handle. We defined our own threshold. In 2010, for example, the definition of the threshold changed and threshold had become fixed. Right? So how it become fixed? Based on the dominant architecture at that particular moment of time, it became fixed. Then what happened later on? Later on, the data set qualifies in terms of volume, right? And we said that, okay, these are the standard architectures that were used, and this is now the predominant standard architecture, which is qualifying only the volume. And that is why this is to be defined as a tick. Okay. But in actually, the scenario is changing. We started with the earlier years, we moved on to the middle era, and then finally we are into now. So you have seen during the advancement, there were map reduced style of a computation also came, right? And there was something called as a big data ecosystem. So what is the plethora of the systems and the tools inside that big data ecosystem? They were able to handle much more. They were very easily able to play with all the 4 V's of the data, right? So in reality, this is the scenario. So the central challenge with the big data is that of devising the new computing architecture or the algorithm is just a myth. Okay, so now, for example, consider an example of a graph. Okay, so just think of that, okay, you have a graph where you are having 40 nodes and some 200 edges. Just think of simply a graph and think of any graph drawing algorithm and start drawing that particular graph. So I, as a human, cannot draw just 40 and 200 edges. Cannot draw in the sense means, if given a small amount of time to me, if I'll consider 40 edges and then try to draw. So, but for the system, but for the computer, just a very small problem, right? So human ability does not scale. We can buy the bigger system, we can buy more machines, we can have faster GPUs, we can have higher storage disks, but the human ability doesn't scale, right? And even when I'm talking in taking an example of a graph where we are having 40 and 200 nodes. So what happens is that we cannot draw it, but for a system, this particular thing is very easy, right? But that particular system has learned during that particular scenario for that particular moment of time to deal with 40 nodes and to deal with 200 edges for that particular graph. Okay. But later on, with the emergence of, for example, a Facebook, somebody says, I even have more than this particular amount of. I have more than 40 friend list. So I have to create an edge for all the particular friends of friend network for that particular user of a Facebook, right? So you have to scale. So Facebook initially was at this particular stage. Then it has to change to something else. And finally, when the number of users increased, they have to change to something. So then you have to think of what the threshold was. So then I'm not saying that it's not talking about, I'm just talking about the central challenge. The central challenge with the big data is that of devising this is what we usually as a big data, or we usually while studying the data science, we usually think. So this is how we perceive the information, and that is how we start writing our papers and we start. So it says not only the central challenge, although there are existing new computing architectures and algorithms into the market, but the only central challenge is not this one, right? So this is just another example. Okay, so have you ever thought of my question to you, but you cannot be able to answer, but just let me pose as a question. If somebody is having a knowledge of a database, what it says is that I'm having a spreadsheet. All of you might have seen a Microsoft Excel. The data is being organized into the form of the columns and the rows, right? So that is, what is it referred to as? It is simply referred to as a Microsoft Excel sheet. So earlier the company was maintaining the data into a Microsoft Excel sheet. Okay, and what happens is the number of the tuples into that Microsoft Excel sheet started increasing, right? So the scientist or that particular manager was facing and saying, okay, I'm facing a big data problem, right? And I have to deal with this much amount of data into my spreadsheet. So the number of rows in my spreadsheet has tremendously increased, right? What should I do? So the simple solution was database management system, right? So you simply move on to a DBMS and you'll find a solution to it, right? So every time moving from a spreadsheet to a database, was it a solution? Question mark. Every time moving from spreadsheet to a database, was it a solution to handle the data? No. I'll let you know. I'm talking about an RDBMS, right? Moving from spreadsheet to an RDBMS, a relational database management system, was not a solution. But why? Because when we analyzed, we had seen that every month a new row was being added. A new row was, sorry, not row, a column was being added. Rows are simply adding because the tuples are increasing. And if I'm adding a particular column, means every month I'm appending a new column. Means I'm appending, or if I'm changing that particular column and the rows, organizing it into a form of a relational database, it means what is happening is I am evolving the database. I am making a change in the structure of the database. So every month I have to run an alter command in order to deal with the schema evolution. So earlier my schema was consisting of 9 columns, right? 9 attributes for that particular relational table. And now if every month a new column is being appended, means the schema is evolving, right? So that particular design may not be suitable. So at times, moving on from spreadsheet to a database fails, right? So although database management system was having good architectures, was having good algorithms, because DBMS was a set of a software which was trying to handle, which was trying to store, which was trying to retrieve the data for us, right? So it was very much efficient at that. But that person who was initially maintaining it in a spreadsheet was not able to move on and take the advantage of the database in this particular case. And then I'll give you another hidden issue. What was there was interdependencies with other components of very complex workflows for that particular industry. So that interdependencies that were being dealt with this, right? So now database cannot handle those interdependencies of the workflows, right? So every time taking the advantage of the DBMS despite of a spreadsheet was not a solution. So this happens at times. Every time we can't say that we are facing some particular issue, and despite of this, if we move on to this, that may be a proper solution to it. Okay, so now what the myth 3 is, right? The myth 3 is analytics is the central problem with the big data. Is analytics the central problem with the big data? The reality is not that, right? So we think of, okay, we have a big data system, so it's a magical piece of a software, and we usually give a big data as an input. It will do some kind of a deep insight. It will apply some machine learning algorithms. It will apply some deep learning algorithms, and it will give me something as an output. So we simply think of it as a black box, right? In order to do an analytics, I'm saying, okay, push big data as an input. This is a black box, and this black box is the big data system. That is a very magical piece of a software, and that is doing something in between ML, AI, deep learning, and producing the deep insights as an output for me. So that is a myth. Analytics is the central problem with the big data, right? It is not like that. So while we are dealing with the big data system, it completely has a life cycle. It completely has a life cycle. It's not just a magical piece of a software, right? So big data is most definitely not ML running on learning on MapReduce. So it's not that. The reality is big data is most definitely not machine learning on a MapReduce. Okay, so if I show you in the next slide, the big data analysis pipeline, it goes like this. So the big data analysis pipeline goes like this. So the first half of the figure shows the big data analysis pipeline and the various steps that are being required in order to analyze or do an analytics on that particular data. And the one shown at the bottom, this particular part, are just the characteristics of the big data. Please listen very carefully while I am dividing the figure into two parts. The upper part is the big data life cycle, or the steps, that phases that has to be dealt in order to do an analytics on the big data. And the lower one are just the characteristics of the big data. So you see heterogeneity, variety, inconsistency, and incompleteness, scale, volume, timeliness, velocity, then privacy and data ownership, and then human collaboration, right? I'll also come to this human collaboration as a research challenge later on. So now, what is the first step while we are analyzing the data is we acquire the data. And from where should we acquire the data? Okay, I'll give you a very simple example. If somebody has downloaded an Arogya Setu app. So if somebody has downloaded an Arogya Setu app, it says, click on this particular terms and conditions, and all of us, without reading the terms and conditions, usually click on that button in order to download Arogya Setu app. In that particular terms and conditions, if somebody has ever read, right, it says that I'll be sharing your data. I'll be first capturing your data, and I'll be sharing your data. So you have given your consent to share your data. So wheresoever you will travel, along with your location, you'll share your details with the Arogya Setu app. And this is how they usually have quantified the regions. For example, then I have entered the information, okay, I was suffering from a COVID. I was a COVID-19 patient. I had this particular information, and then they analyzed, okay, this person had given this information. This is the thing being stored into their database. They analyzed it and they predicted as a red zone. So they had taken the consent from us only. They had collected the data from us only. But we, not being working into a data science or a database domain, didn't even bother to read those terms and conditions. We simply clicked on it and we said, okay, that's a mandatory thing. If we have to enter some government premises, Arogya Setu is a must, and I have to download it and I have to give my data privacy concerns. So it means every time I'm being tracked. But they are analyzing and they are categorizing, okay, this is the red zone, these many number of COVID patients are there currently in this particular zone. This is another zone, these many numbers, so it's maybe into a yellow zone. And then this may be into a green zone, depending upon whatsoever information they gathered from us. Right? So, but that was the data acquisition part. So it means whatsoever data they are acquiring is trustworthy. They are assuming that the quality of the data they are capturing, for example, is trustworthy. Right? Is because the user is not entering it, but the system is analyzing and taking it. But while if I'm telling you to fill a form, despite of a numeric that was to be entered, you might have entered a varchar or something else. Right? For example, I asked for the age and you had filled Shelley as an age. Right? There was no particular on the Google form. I'm collecting the data from you. Right? I'm asking for an age and I was in so hurry to fill up the form. Despite of the name column, I filled my name as a Shelley, and there it was the age was there. I also filled the Shelley. Getting it? So that data, while collection at the back end, when I'm trying to analyze the data, how can the age be Shelley? But there was no restriction on the front end that it was an integer. And it has to be into a numeric form. So the data acquisition is the first part, right? Then the information extraction and cleaning, right? So information extraction and cleaning, for example, some other customers were also asked to enter on the age. They don't want to, and it was not a mandatory thing. It was left as none. So information was being extracted now, right? Information was collected. Now we want to do an information extraction. We need to do a cleaning. So if we are analyzing on, for example, if there was 100 null values in a data set of 200, and I'm trying to analyze the data, I'll not get the same results because 50% of the entries were null. So 50%, I cannot train my machine based on that, right? So how I analyzed it? While cleaning or information extraction from that data, I analyzed it, right? Then data integration, aggregation, and representation. So it might be possible that I might have collected data from one end, right? I may have a data source from another end, and I would like to integrate that, right? And then based on an aggregation of that, I would like to do further data analysis on that. But that data integration, for example, you had some data from an ICICI, you had some data from an HDFC, and you had some data from SBI Bank, and you want to integrate that data and propose some wisdom on the top of it. Okay, so one HDFC named my customer ID as CUSTOMER customer ID. HDFC named it as C_ID, right? And third, SBI named it as CUST_ID. Now, while doing an integration of the customer ID, all of them are having different, representing it by a different attribute name. So first, the mapping needs to be done. Okay, this attribute, and this attribute means the same. Right? So data analysis is not something like a magical piece of software. You put the big data into it and you'll extract some particular insights. Of course, you can do that, but that will be meaningless because all these phases are just as a pipeline. Okay, so then you do a modeling and an analysis for that particular data, and finally you interpret. And that interpretation should also be from the domain experts. It should not be something like me analyzing the healthcare data. I don't have any information that whether this person will be suffering from a tumor or whether if this value is this one, this is what my machine is predicting. But am I interpreting the data which was there that belongs to a healthcare category should be interpreted in terms of a healthcare by a healthcare worker, right? So that is why usually at times if we are analyzing the healthcare data, the researchers usually ask, has the usability study been done from the person from that particular domain, right? So at times we need to refer to a doctor in order to show, okay, this is what we did as a machine and we trained it. Now, can you interpret and see whatsoever the target was is being achieved or not? And in between, you can see these arrows coming in and going out, coming in and going out. Despite of a pipeline, what you can see is the arrows are coming in and going out, coming in and going out. What does these arrows depict? These arrows depict feedback. So each and every phase is taking some input while doing this. So it's a constantly improving itself. So that is the big data analysis pipeline. But simultaneously, you have to deal with the characteristics of the data. So that is why the myth is the analytics is the central problem with the big data. So that is why it's a myth. So the analytics, the big data analysis pipeline should be known to all of us. Then these are the various phases in the big data life cycle. So the first decision I had already explained. This is the first one, second, third, fourth. So it has given you a brief interpretation of each of the steps of them. Yeah. Then I was giving you an example of a real-time streaming. I was telling you that real-time streaming is happening via batch processing or a stream processing. So it just shows you an example of a stream, what a stream is. Okay, so this stream is an enterprise grade that usually helps to make the intelligent platform to build continuous streaming data pipelines. So I've shown you an example of a data analysis pipeline. I'm giving you an industry example. So stream is an example, and the figure shows that it provides a platform to extract the data from the cloud, right? And again, send it back to the cloud after the real-time change event. For example, this is what stream provides. So it just extracts first of all from the cloud, and then it returns back to the cloud. So you can see that what this big data analysis pipeline includes. So it deals with the number of databases where I was talking about big data and NoSQL, then heterogeneous databases, the cloud services are also there, plus is there. And this is the complete pipeline it is dealing with. Continuous real-time pipeline monitoring with metrics of change data, in-memory transformations is there. Then checkpoint for exactly once in order to satisfy the asset properties, then the schema change replication, the distributed change data. So this is the complete work, complete things that is happening. So it's not simply an easy task, right? So they simply have to do the visualization, all these things needs to be done in order to exchange the data. First, getting from the cloud and then sending back to the cloud. Now, the myth 4 is the data reuse is a low-hanging fruit. People think like this. People think if I'll get a data from a cattle, right? Or if I'll get a data from some particular source, it will be very easy for me to apply it into my algorithm and to show that, okay, the results perfectly went well. But it says that I'm reusing the data, right? So I think it like, okay, it is okay, and from the smaller place, let me pick up that particular fruit, and that fruit will be very tasty. So that is why I usually say, okay, let me move on to Kaggle, or let me move on to some particular other thing, and let me reuse the data. But what in actually the scenario is? What in actually the scenario is the challenges while I'm reusing the data. What are the actual challenges while I'm reusing the data is, first, the first challenge is the original data set has to be found at the time of the desired reuse. When I have to reuse it, I have to find the original data set. I have to see with which particular tag sets that particular data was being identified, right? So tagging, if somebody has the learned or knowledge about the machine learning, supervised and the semi-supervised, may be able to understand how to add the tag labels. For example, I can give you an example. When I'm talking about an RDBMS, I'll usually tag it by an attribute name and the name of the table, right? So this is how we usually tag the data sets. So first of all, I have to move on to the original data set. I have to find it out. Okay, how they were being tagged. Okay, they were being tagged by this attribute and this particular name. But now the problem solution for which I am trying to reuse the data, right, might be having in the large universe of the data sets, they might be having other that are similar, that are of similar interest. So why should I go for this particular and why should I not go for this particular? Because in the large universe of the data sets, right? So these were the ones, and in relation to that, the other topics of interest are also depicting that, right? So the first challenge is, which one? Is this the one should I go for? And in actually the attributes, the same topics of interest were being used for this one and for another one. Then how to have a relationship among them. The second challenge is the data sets must be understood and interpreted in the terms they were to be interpreted to make them reusable. And for that, what you require is you require a metadata. Metadata is data about the data, right? You might have named an attribute as something C_ID, but how will it imply that it refers to the customer ID? The particular company might have something else into the mind and they might have given this particular name. And I'm using the data set with the particular thing that was referred to as a label as a C_ID. And my assumption is this C_ID is the customer ID. Whereas when without looking at the metadata details, I cannot imply this C_ID is the customer ID, right? So before reusing that data, I need to understand, and it is interpreted to be reusable. Okay, so precisely then, the next thing is precisely under what condition the data was obtained, using which particular instruments the data was obtained, and after what kind of a sample preparation the data was obtained. Okay, I was lying on the bed in a very, that mood, right? Then somebody measured my blood pressure and somebody recorded it, right? And then the doctor asked, okay, what was the blood pressure? Then they recommended and told, okay, this was the blood pressure, right? And while I was sitting and my blood pressure was being recorded and the doctor asked what was the blood pressure, it was being told. So there is a variation. Which particular instrument was used? Was the digital or an analog instrument was used? So there is a change in the reading of the blood pressure. While in which particular condition I was lying, whether I was lying on a bed, whether I was sitting, or whether I just came from an exercise and I just measured my blood pressure. So of course my blood pressure was going to be high at that particular moment of a time. But I haven't informed this thing to the doctor and the doctor prescribed the medicine. So in order to make these similar is the case, in order to make these data sets understood and interpreted for them to be reusable. So we think that data reuse is a low hanging fruit, but in actual we have to address these challenges, right? And the third challenge is the data sets found are quite not into the right form for the desired use. Right. For example, one data was collected from the school district and another data was collected from the country. Right. So they are not quite in the right form for the desired use. So they first of all have to be brought because they were being gathered for some other purpose. And we are trying to solve a different problem, a similar kind of a problem, but then we have to first of all bring that particular data into a desired use. Right? Even that I face these kind of problems. That is why I found these particular challenges to be very interesting. I was making use of a standardized healthcare data set. I was working on it, right? And it was being gathered for some particular use for their purpose, right? And I was trying to extract, okay, what will this person suffer from a tumor or not, something like that. So then when once I dealt with that data, I worked on the nephrology data set and then I tried to analyze it and use it for a different purpose. So this is the problem which I usually faced. So was the purpose of that particular data set collection the same as I want to use that particular data set? So these are the particular challenges. So you can reuse the data, right? So data can be reused, but in order to reuse the data, these particular things needs to be addressed, right? So these are some of the pros and these are some of the cons of reusing the data. Okay, so the pros are the data sets are impossible to create, sometimes reusing helps, and the cons are the data may not match the research question, So when to go for a data reuse and when not to go for a data reuse. So you have to think in your own terms. You have to think from your particular research perspective, right? So although it is a cost effective, otherwise if I start collecting the data from the scratch, my 1 year goes in simply collecting the data, right? So do not have insider understanding of the data and the data collection. That there are ethical issues about data collection dealt with, effort to get to know the data, then do not need to recontact data subjects. Ethical issues about data you still apply, you reuse the data used by others to make claims, you cannot extend the standards, right? So these are some of the advantages. So whenever we usually refer to that particular data, we must cite it, okay, that we were used. And these are the challenges of using the data. I've already told you there are challenges on the based of the technical side, as well as there are challenges based on the ethical ones. Okay, so the technical challenges are where can the data be found if they haven't shared, if they haven't been shared, right? And what are the ethical issues are level of data trustworthiness, the informed consent, the anonymity of the data, then recognizing the authorship of the data. So if we have reused it, so these are some ethical issues are there. We should always say, okay, the data has been picked up from this particular thing into which was published into an open domain and we have reused it. Now the next myth is, yeah, that's very interesting one, which says, is the data science same as the big data? And usually most of the people nowadays use the two terms interchangeably. But actually, this is just a myth, right? So when I'm talking about a big data, it begins with the characteristics, right? And it moves up from there. And when I'm talking about the data science, the reality is it begins with the data use and I move down from there. So this is the basic thing which we should remember. What is to be done when I'm talking about a big data, it begins with the characteristics, the volume, the velocity, the veracity. So that is from there we move up. And data science is, it begins with the data use, right? And from there we move down. So the definition, this is an example to big data. So this is, it's simply showing you, okay, what was happening and how we had a tremendous increase of the data in from 2010 to 2030. So every 60 seconds, the many number of tweets, this was there, but now more number of people, we have more mobile users, we had more web users, and this is how the tremendous increase of the data happened. So this is where I'm saying that data science is the use of the data. So I can use and apply the data science into a healthcare domain. I can apply it into a fraud detection kind of a scenario, the internet search. I can apply the targeted advertising, the gaming, the augmented reality, the airline route planning. So these are some of the examples of where the data science can be deployed. So almost in every sphere, I would say, maybe an IoT domain, maybe a healthcare domain, maybe a financial sector, every particular sector can make use of data science. Then, so this is just picked up from a particular source, which I found to be quite useful. So the big data analytics and the data science analytics, so it was just differentiating between the big data science, big data analytics and the data science analytics. I guess I should come to it at a later stage after starting and giving you the precise definition from an authentic source about the data science. So now the last myth about the big data is all hype. What it says is that were not we dealing with the databases? Were not the data analysis being done by the statisticians at an earlier, in previous, if we look some 30 years back or 20 years back, was there no data analysis? Were there not databases which emerged from 1970s? Were there no databases? Right. So what is this exciting thing about the big data? Question mark. What is this exciting thing about the big data? How come it come out of a sudden it says, okay, big data, big data, big data. Everybody is talking about a big data. Everybody is looking for a data scientist as a job, right? If you see onto the LinkedIn, the number of jobs for the data scientist on an average you found to be too much. So am I a statistician? Am I a mathematician? Am I a computer scientist? Or who can apply for that particular data scientist job? All of us. Me as a mathematician can apply, me as a computer scientist can apply, maybe I might be working into a healthcare domain area, into a health informatics, can apply for a data scientist for doing an analytics on the top of healthcare data, right? So it's just big data is all hype. And who created this hype? First, the industry. Why? Why the industry created this hype? Of course, you know the answer to it. The money was the main concern. Right. So the money was the main concern. So what they did is, while storing the data, right, they stored the data in such a particular manner that to the client side, oh, it's very difficult to do everything. Right. So big data is all a hype. They usually make the big data as a hype. But if the industry people will be doing like this, the clients will be running away. Maybe at an initial stage, they may be considering, okay, they want to earn a money and they may be paying us. But then at a later stage, they think no, because they cannot spend so much amount of money. The big companies can. For example, I give you an example of a grocery store, right? So a grocery store, one of my student was working on as a freelancer. So the cost that the particular grocery store got for making a grocery information system for them was just 50,000. They just said that, okay, I'll cost you 50,000 bucks and I'll create a grocery information system for you where you'll be able to do an online billing for your system. Okay, so this is what they assured, and the other person, not being from the technical background, was okay. Then the student who was acting as a freelancer, right, one of my students, had quoted the same grocery store. I gave the reference, and my student quoted 1.25. Despite of 50,000, he quoted 1.25, right? And then that particular grocery person was like, how come? So of course he'll be going for that 50,000 one, but how come he costed 1.25? Look the way the people are making money. He costed 50,000, right? Then whensoever there is a new inventory, then that they will take the support and maintenance fee, right? So every time a new product is being entered into that grocery store, need to be managed by that particular person. So he'll charge on 6-month basis, and this is how he'll make that money. And whereas the student who was a freelancer said, I'll be providing you a content management system where there'll be a simple prompt telling you to upload the image of the product, enter the price of the product, enter the name of the product. So the grocery person himself, without requiring a support, will be able to upload the products. And those products will automatically be added to the billing information, right? So everything was there. The content management system permitted the grocery store or owner to be now act like an administrator. And that 6 months cost, which the other vendor was charging, was not being charged from that particular freelancer. So this is where the difference is. So they just make, okay, your data is so big, and your grocery store is this. Then we'll charge you first of all 50,000. So that person was attracted that, okay, they're charging me, but he didn't mention anything regarding the maintenance cost. And the other person who charged 1.25, right? So this thing needs to be explained to the other person in order to make them understand that what they are paying is worth it. Getting it? So that is why big data is all high. That is the myth 6. So this is just a simple example to make you understand that, okay, what is happening in the world and how we are trying to grasp the big data as. Fine. So now nearly you have seen number of call centers also, right? So call centers are working on the data, they are trying to analyze and then recommending, okay, this is what is being done. So this I analyzed while they were having a set of a data, they were analyzing something without being aware of which particular algorithms are being linked. They had some particular patterns, they were working with plugging and playing with some very good software tools by that particular industry only, and they were trying to analyze, making very good graphs. Okay, this is what happened, and they were making full out of that particular company that your initial sales started with this, and this is how good the graph is, and this is how your this has increased, or something like that. They were just analyzing their data. So every field of endeavor usually is transitioning from a data poor to a data rich, right? And what is the example and why they are transitioning from a data poor to a data rich is the first reason for transitioning in is the very cheap storage. And the next thing is, the first one was the data storage was very cheap, and the next was the collection of the data. So the collection of the data was very cheap, and the next one was the storage of the data was very cheap. So because of these reasons, there is usually an endeavor in transitioning from a data poor to a data rich. So moving further, this is just an example to show you. Yeah. So here is where the data science is. So this is a definition by the National Consortium for Data Science. In 2013, they published this particular definition where they called the systematic study of the digital data using scientific techniques of observation, theory development, system analysis, hypothesis testing, and rigorous validation. So it was not that in the past era we were not dealing with it. We were dealing with it. We were doing the theory development. You are learning that into the theory of automata course, right? We were having the scientific techniques of observing the data. The astronauts were the ones who were gathering the data, taking the pictures, and actually analyzing and making some observations based on that. Then there was a systematic analysis based on the statistical theory, and there was a hypothesis testing also, right? So if you see the lemma, the proofs, and all that, and finally we had the rigorous validation also, right? So all this was happening prior to this particular data science comes into emergence, but the data science is just a bigger thing, right? So that has an amalgamation of that was happening separately. So it just combined everything and presented the term as a data science. Okay, so I'll give you a very clear picture of that the big umbrella of data science includes how does it deals with ML, how does it talks about data analysis, how it talks about data analytics and all that. So what is the key purpose of the data sciences? So this national consortium only had given this particular key purpose of the data science. It says that you are creating the knowledge about the properties of the large and the dynamic data sets. We need to create the knowledge, first of all. What properties does this particular data set, this large and dynamic data set possesses what particular properties? Then it develops the method. So the key purpose of data science is not only one. It has to do the complete thing, and that too into very systematic order, right? So it develops the method to share, manage, and analyze the digital data. Then optimizing the data resources, where we usually are talking about the factors such as accuracy, latency, and cost. So this is the complete key purpose of a data science, to create the knowledge, to develop the methods, and to optimize the data processes. So that is why the toolbox is very huge, right? So I may be into a team where I'm just doing this particular part, and I may be working into an industry working on this particular part where I'm developing the methods to share, manage, and analyze the digital data. And there might be a team who might be optimizing it. If you take a simple example of an Amazon has a separate team, right, which is dealing with this optimizing data processes for factors such as accuracy. For example, you are simply typing on an Amazon button search. search button, and at the back end, there is a query that is being fired. And that query has to hit the database and bring the results from that particular database. For example, if I search simply a laptop, right, and that to an HP laptop. So what the query at the back end is running is select what? Select the attribute. That attribute name is there. So select the name of the attribute is the laptop. So select that laptop from that particular table named as a commodity, for example, and then where condition is where the laptop is equal to brand name of brand is equal to brand is another attribute is equal to HP. Now this particular query, for example, is running at the back end, right? When you are simply typing this, you are clicking on the search button. That particular query has to hit the server, see the network traffic also, right? So many particular users are trying to fetch this detail. So this query is running at the backend, trying to fetch the server. From the server, the database is kept, trying to get the answer from it and returning back to the customer within a fraction of seconds. Within a fraction of seconds. You never even analyze how much work the particular community, the particular researchers had put in order to give you an efficient result on a search button for that particular Amazon query. You simply had a search button and it was very much easy for you, but you never have analyzed the amount of the work that was put by the Amazon team and different set of teams. So they optimize the data processes. They want that their customers cannot wait, right? So they cannot compromise with their customers, and that too they have to first of all compare what was the cost being given at other sites and what are the costs they are offering. So they have to analyze it. So this is analyzing the digital data example. So of course the Amazon is doing it, of course the Facebook is doing it, so everybody is doing it. You just have to think of the examples, okay, where they are trying to do it. First of all, they are trying to create the knowledge, right, about the properties, and then they try to develop the methods in order to analyze the digital data. Then they optimize the data processes also. So they have, that is why a separate team, separate set of people, those who are specialized in this one, those who are specialized into this one, and then they collaborate. So finally they go for a testing, a validation. That is usually have started into software engineering terms. Okay, so these are the domains associated with the data science. So I already informed you the e-commerce domain is there. I've given you an example for an Amazon, the finance, given you example for a banking also, the aviation sector also. So from informatics, the healthcare team is the transport is also the domain associated with the data science. And if you are talking about a business, the manufacturing domain nowadays is making, okay, how does they analyze? Okay, how much particular Maruti Suzuki's or Mahindra, this particular model cars should be produced. So first they analyze. So they do a data analysis kind of a thing, and this is how they analyze, and then they manufacture that much amount of a car. So it's not like that they simply think, okay, start manufacturing. So this is how usually the domains associated with the data science. So this is what usually a data scientist is doing is, so giving you a very clear picture of, yeah. So giving you a clear picture of this one is here what we started with the data. So if you see it simply emerged as this thing, then you as a data scientist need to sort the data, right? Then you need to, of course, arrange the data, and to some companies, even if you show a visual representation, they are quite satisfied with the visual representation of the data. So I've shown, okay, this for this one, this for this one, this for this one, this for this one. So I'll give you a very good example of a Lay's, usually how the Big Bazaar data is being analyzed. They had n number of commodities. They sorted it out. Okay, this is Lay's. This is the information related to the blue Lay's. This is the red Lay's, and this is the green Lay's. And these are some other products, of course. So then they arranged it, and then they analyzed. Okay, the black Lay's were the one which were not being sold, but the yellow Lay's and the red Lay's were the one which were sold. Like if you put this, so yellow Lay's were the ones which were sold, and the red Lay's were the one which was sold, but black Lay's was usually launched very recently, and people are not aware of it, so that might be the reason. So what they did is they made a combo. They made a combo scheme where, despite of a 20-20-20 pack, they reduced it to a 50 rupees. So they were knowing that their black lace are not being getting sold, but they want to avoid a loss of 20 rupees. So they said that, okay, a loss of 10 rupees might be okay, or whatever they are earning from a yellow and a red lace will suffice for that. So they started selling black lace in combo, so that at least the people should be attracted like this. So this is how the data scientist explained with a story. Getting it? So I was just moving on to a LinkedIn and doing something, and I found this particular picture from the LinkedIn where somebody had very well elaborated this thing. So I picked it up from LinkedIn, this particular picture. Okay, then this is what the job of a data scientist is. He may have the knowledge of the math and the statistics. He may have the knowledge of a programming and a database. The domain knowledge and the soft skills are also there within. Then the communication and the visualization is there. Okay, so the main thing is what I would like to point here as a challenge, while the modern scientist, what particular knowledge the data scientist has is the human interaction. So if you produce some particular software and that is not interactive for that particular person, right? For example, my end users were, for example, doctor, and the doctor is not able to interact with the system, right? Despite of giving very good result from a data scientist perspective, it's of no use. But me as a computer scientist is very much aware of. So you can think of the human interaction interface for the Amazon. So Amazon has such a good interface that despite of having the knowledge of the SQL queries or the NoSQL queries, so Amazon also makes use of the relational database management system also and the NoSQL category databases also. But the front-end users are never aware of that. They're not even thought of that they are doing or providing a recommendation based on that. They're very happy with, okay, recommendations. The customers who purchase this, right? But if we are not working into a technical code databases or data analytics or a data scientist as an area, we are very much happy with the recommendations. But how those recommendations came? It means that the data was being analyzed at the backend team. They collected the data. They served my history, where from which particular tab I moved on to which one, from which particular tab I moved on to which one. So customers who purchased HP laptop also purchased the accessories related to it. That comes as a recommendation. Agreed? So this is how what it happens, but they had a very good interface. At the back, at the bottom, they had a recommendation. So is somebody telling them that, okay, this is the wisdom part we are providing to you. But in actually, they are started with the data. They're converting it into an information. Finally, they are trying to extract the knowledge out of it. And the recommendation system is being provided as an output to the customers. So this is how they usually learn. And they usually keep on refining their particular interface. But the human interaction is the one. So they are thinking, and then they were thinking, okay, the elderly people are not able to do shopping. Then they introduce some kind of a Siri kind of a functionality. Okay, you just speak, and then the particular item will be shown to you. Despite of writing, if you don't know the spellings of that, maybe a Siri kind of a thing being appended to it. So this is how usually the modern data scientist is analyzing the things and putting it at the front end so that the human interaction part is very strong. So if you want your product to be usable, just think of what is the domain knowledge of the end users. And was the thing that you designed is quite easy for that end user? If yes, then go ahead with it. So this is what a data scientist is doing. It is understanding and trying to understand the problem and the domain area. Based upon that, he's trying to collect the data, right? Then he cleans and processes the data, right? So I'll show you a case study also for a diabetes prevention, just a very, very small and very simplified case study where I'll show you that how we cleaned and we processed the data. Then we explored the data and did a feature engineering on the top of it. And finally, we analyzed and predict. So this is what usually a data scientist is doing. But in order to do that, it's not just the one day task. he really has to spend time in understanding what are the various algorithms that can be used, right? So has he to apply some interpolation methods, or has he to do something else? And in the feature engineering also, he has to look into the details of the techniques that are available for feature engineering, right? And for analysis and prediction, or if you are already aware, since you have been a machine learning expert or a data like a deep learning you are working with, so you are available, you are known of what are the prediction techniques. So these are the tasks of the data scientist, where you learn the business problem domain, you identify and specify the social and the ethical issues such as the privacy and security. Because the customer would never like to compromise for the privacy and the security. So that is why a data scientist has to be very much careful and think about how to retain the privacy and the security concerns of that is why Arogya Setu, first of all, had taken the consent from you, then only taken the information from you. So usually whenever either I'm clicking on a Google some terms and conditions, or I'm clicking on something, some particular app which I'm trying to download, or usually the people are very much game lovers. So those particular people must see the terms and conditions before downloading the app. So you'll be able to understand what privacy and security concerns you are losing in order to do that. Then understand the data characteristics and the complexities. So I told you that's very much important because you want the qualitative results from that. Then set up an engineering and analytical processes for turning the business and the data into an information. Then to transform the business problems into the analytical task, because the client side will never say what analytical tasks you can provide, right? Because the person never had expected, okay, the Amazon will give a recommendation kind of a system. Initially, when the Amazon started, Amazon was not offering such kind of recommendations, or the customers also viewed kind of a scenario at the bottom. So now it gives like this. So if you see a Shopper Stop website, they usually earlier were not so much to adapt. But if somebody has tried doing the shopping from an Amazon, they are usually also moving on the good interface that Amazon was provided. So Amazon is given the highest rating of considering the e-commerce sector. So most of the people usually trust either on Flipkart or they trust on Amazon for doing the shopping. And usually it says that Amazon certified and other tags also, right? So they are trying to analyze the data. They are trying to see based on the user's feedback, based on the user's ratings. So the user's ratings are also analyzed. Okay, so based on the understanding of the data characteristics and complexities, extract, analyze, construct, mine, and select discriminative features. So this is what in actually the task of a data scientist is. Then they combine analytical, statistical, algorithmic, engineering, and technical skills to mine the relevant data. And simultaneously, they have to think of to maintain the privacy and the security of the data, right? And usually it is engaged whenever I'm delivering some particular product or the industry is delivering, they usually have client interaction during the whole life cycle. That is why the feedback buttons were there. So while the complete process, they usually have the client interaction and they usually ask, okay, is this as per what you want? Is this as per what you want? Or we want something to be changed? So that before delivering the product to the customer, they usually, first of all, do this analysis. Then these are some of the tools of the data science. We have R that is used for the statistical analysis. We have Apache Spark, that is fast analytics engine for large scale data processing. We have Big ML, which makes machine learning for data science easy to use. Then we have D3JS, we have MATLAB also. Then we have SAS. Nowadays we usually have a Jupyter as a very platform which can transform and which is used for visualizing the data. Then we have a Tableau also. Then ggplot. So these are some of the tools that may be used for the data science. Then this is the little bit description of the tools that usually the data scientists are using. So if somebody would like to go for a cloud infrastructure, can make use of Apache Hadoop, Spark, Cloudera or AWS. Then data and application integration. For doing that, you can refer to the IBM InfoSphere data stage or Oracle data integrator or a SAP data integrator. Then for master data management, these are some of the tools for data preparation and processing. You may have a Teradata Loom or an IBM SPSS for that. Then for analytics, we usually have IBM SPSS Modeler and SPSS Statistics. We may make use of a MATLAB, a RapidMiner, and many new tools have already been created, such as BigML and MLBase. For visualization, it says that it's R also provides some kind of a visualization, but these are very good softwares for doing a visualization. Then programming, you can have any language such as R, you can use SQL, you can use Python. So new libraries are being added to the Python these days. And even Java was trying to add some more libraries for doing an analytics. But I guess Python is the one which usually the students usually prefer to go with in order to do an analytics. Then for business intelligence reporting, Excel, IBM Cognos, and then SaaS business. So these are being used for business intelligence purposes reporting. So this is what I was trying to say to you, that this is a bigger umbrella. Okay, so big data science is a bigger umbrella where I'm having all these things. I'm having a data analysis, and finally I'm having this analytics. So everything comes under the data science. So data science is a bigger umbrella. Then comes under this particular umbrella, we are applying these particular artificial intelligence, machine learning, deep learning, everything. We are making use of it. We are analyzing the data and we are doing an analytics of the data. So under the analytics of the data, the data can also be classified as a proactive, prescriptive, predictive, diagnostic, and descriptive. If somebody would like to go into the details of this, there's a very good paper on depicting all these particular things. So I've added the paper and the references to it. So under the data analysis, these particular things, and this is where I was talking about. So usually the people says that, okay, I'm making use of an ML, that is why data science. But data science is a very bigger kind of an umbrella, which requires the data analysis and analytics, and these are the techniques through which you can achieve that. So deep learning, then, so AI is a bigger one. Under it lies the ML, where you are dealing with a supervised and a semi-supervised and an unsupervised or a reinforcement. Then under it is the neural network, and finally under the neural network we have the deep learning. Right. So earlier we were just plugging and playing with the ML, but nowadays we are for very big size images we are doing making use of our deep learning also. So that is why I was telling you the data is there with us, the data science is there with us, and the keystone for doing the data science is the data analytics. Right. So data science, this is the definition which I was referring. It's from an authenticated source. This is the definition that I wanted to show to you. So data science is a systematic approach to think critically with intelligence, using the domain knowledge, the management of data, computation of data, extraction of knowledge, provide the data products, and best and optimal action and insights. So I had drawn the diagram where I had the amalgamation of 3 domains, right? And after that, I added the environment, I added that, and then as the data products we delivered, either we can have a decision or that thing were being delivered as a products to use. Then data analytics is what? It understands the data. It extracts the knowledge and provide actionable insights. And so keystone for doing the data science is analytics. So this is how usually we differentiate between the data science and data analytics. Okay, so that is why we consider. So if you remember just this particular diagram, that this is the data, and on that data we are doing the data science, and the keystone to doing this particular data science is analytics. Okay, so this is how we usually have a representation of the data science, then data analysis, and then data analytics. Okay, so here we usually use the theories. So we may use ML, we may use neural network, we may make use of a predictive modeling techniques. Okay, so for doing any kind of an analytics that belongs to either the descriptive, diagnostic, predictive, or prescriptive analytics, we usually are applying either the ML other neural network, or predictive modeling. So that is why data science is a very bigger umbrella. But the data analytics is the keystone to achieve that particular data science. So this is the complete life cycle, just to give you an overview of the various data analytics, various phases. So now the future of the data science, where the future is. So future of the data science is to design and develop the data frame that can autonomously mimic human brain working mechanisms. Okay, then deepen understanding of the data invisibility to understand their complexities and intelligence. Then is to invent new data representation capabilities. Then is to design new storage, access, and management mechanisms. Then to create new analytical and learning capabilities, to build new intelligent systems, to train the next generation data scientists and data professionals, and finally, to discover and invent data parts. So this is where the future of data science is. So still we are doing it, and still says that the future also lies with the advancement of all of that. Now, since we had already learned about big data, the various myths, the realities, and so is it, question to you is it possible to do a data science without a big data and a vice versa? So usually when I think of, the first answer from the person was no, because they usually think of that nahi, data science hai to big data to hoga hi, right? But it's not so. Nothing stops data science without doing the big data, right? So it's possible to do a data science without a big data, and even the vice versa is also possible, right? But it says that you may have a big data and you can do a data science with that, right? So that is why the particular myth that was there was being cleared at that particular time, that data science and big data are used interchangeably. But in actual, you can do the data science even without the big data, and you can even the vice versa is also possible. Then what are the challenges for making the data usable during the data analysis phase, right? What are the challenges for making the data usable during the data analysis phase, right? We talked about the use of the data, and we talked about making it reusable, right? So data collected by a domain expert with limited database expertise. So this was the challenge. That is why the analysis was difficult. Now the data was being collected by the healthcare worker, and we as a data scientist are trying to analyze it. So data was collected by a domain expert who was not having the database expertise. And some vendors, I told you, intentionally keep them hard because they want to have a monetary gains. They want to have the consultation fees. But in actually, we'll lose the business if we'll keep doing like this, right? We have statistically naive users making unsupported assumptions about the data at the hand. Example regarding the independence or randomness or how representative the data is. So the naive users are the one, right? Those who are just thinking of, okay, the randomness or the representative data set is. That is why the data analysis becomes difficult. So now these are the research scopes or the areas where we can work on. We can work on the human interaction part. We can work on the database and data analytics usability research, right? Because until and unless the usability is not there, right, we cannot create such kind of an interface which are very much usable by the end users. Our complete database research is waste, and our complete data analytics research is waste, right? The next is the data privacy, where we can work on. Right. So in the data privacy, I've given you ample amount of examples, either from the Facebook or from the Arogya Setu app, or from whenever I'm clicking on a terms and conditions, how we use our privacy concerns. Right. Then some of the very good particular tier 1 conferences I should mention. So first of all, if we want to know the advancement into these particular areas, we should always refer the paper from these communities. IJCAI, then AAAI, then BLDB, Sigmod 1. To get 3 SCI paper is quite easy than getting 1 BLDB paper or 1 Sigmod paper. Although these are conferences and they have their specific journals also, BLDB also has the journal associated with it, and similarly Sigmod also have, but these are the tier 1 conferences. So researchers usually take 2 years of time in order to develop what they publish in BLDB. And later on, this is what is being used into the industry. right? So I was giving you an example that Amazon की query बहुत जल्दी answer apply करती है कैसे? So the database researchers, those who published into the VLDB and the Sigmod domain, are the one who worked on the optimization techniques that is being used in order to give a fast retrieval result of an Amazon query, right? Then ICD is next conference. Then IEEE Big Data Initiative is the one which you can refer to in order to see what are the various research and challenges addressed over there. This is from the paper, the survey paper, right? So Data Science, a Comprehensive Survey was the paper from where I picked up this particular definition. So I found it to be quite interesting. So you can refer to the paper from an ASIM computing survey. The paper is referred to as data science, then followed by columns, the comprehensive survey. So it gives a very precise information. So if somebody is teaching a course on a big data or a data science, can refer to that paper in order to make their students understand the basic definition of what a big data is, what a data analysis is, what a data analytics is, and so on. What a data science is, and how should you define a data scientist, what are the different kind of analytics, so that can be referred. So with this, I would like to end up my presentation. So any questions are welcome.
Participants, you're open to ask the questions. There was a question, but ma'am, you have already shown that in your slides, that what is the main difference between data science and big data?
Yeah, okay. I'll let you know what is the difference between the data science and the big data. Although I already covered that, but I'll reiterate it. So big data is when I'm talking about the characteristics of the data, and there is from where the big data starts. And data science is the use of the data, and we move down from there.
There's one more query. What do you think are the criteria to say whether a developed data model is good or not?
What do you think are the criteria to say whether a developed data model is good or not? Okay, yeah. So Naveen, I would like to answer to that. How should I say the data model is good or not? You have to first of all think that the model that you have designed is being used for which particular purpose, right? So after thinking that, okay, this particular data model was being designed for this particular domain area, depending upon that you can analyze it can be good or not. Masters is important to have a good career in data science. I cannot comment on that because some of my BTech students are really doing a very good project, making use of Python libraries, and they have even got a package of 55 in Adobe. So I would not like to comment on that masters is important to have a good career. That totally depends in which particular domain area you are interested in. If you want to move on into an industry and if some package is being given like this to you, you can even sustain with a BTech. And if you want to be into an academia, yes, of course, a master's and a PhD is of course useful to you.
Participants, any other queries? I think, ma'am, we are done with the queries. So in case if anyone comes up with any other query, our team will be in touch with you. And just ma'am, one more request. Many of the participants, they have requested for your slides. So would it be possible to share the presentation, the PPTs that you have just shown?
Yeah, I'll share it. I'll send an email and then correspondingly you can share it with the participants. Okay.
Just one query, just right. Is it possible to do data analytics without having knowledge of tools of coding and computer science background?
It's possible to do data analytics, but in order to implement, of course, you need to have the knowledge of the tools for that, right? And there are very good tutorials for an hour. It will hardly takes you like 2 days. So such good tutorials are already available. It will hardly take you 2 days to learn a particular tool. For example, for an hour, you can see a simple tool, and I usually teach it in one lab to my students how to plug and play with that. So it's not really that you should be from a computer science background, but if you see or refer to a very good tutorial of that particular tool, even a student not having a computer science background can do that, the data analytics. But of course, you have to make use of a tool. But in order to learn a tool, it's not mandatory. Tableau is a very good software. Then, okay, where is University of Aizu? Okay, University of Aizu is in Japan. It's a Fukushima prefecture. Everybody remembers that some particular kind of a typhoon came, and in just a duration of 20 days, the systems were back, everything was back. So by that particular prefecture, Fukushima, that is a prefecture in Japan, usually the person can recall, okay, how the Japan in a span of 20 days were back to the normal even after a heavy typhoon and such kind of a scenario came. So it's in Japan, which it's like we have to take 2 trains in order to reach to Aizu from Tokyo.
This is one of the most common queries which most of them ask is one tool sufficient? Like if someone is preparing
One tool, no, for doing a complete data analysis pipeline, one tool is not sufficient. But if Sonam, you are working into a specific tool, a specific team, for example, I very clearly mentioned that you might be working into a creating a knowledge team, you might be working into a developing team, right? So then, of course, one tool is sufficient. But if you want to do a complete data analysis pipeline, of course, you have to analyze the data, you have to apply the prediction techniques. So one tool may not be sufficient.
Okay.
Okay.
Thank you so much, ma'am, for such an interactive and
Okay.
Thank you so
much. Thanks to GL Bajaj for giving this opportunity to me. Thanks to Dr. Kavita. Thank you so much, Navita ji. Okay.
Thank you, ma'am.